yesterday we started with our improper integrals. Remember we said we have two types. The one where our bounds are infinity, which is what we're finishing up today. Then we're out of school Monday. So Tuesday we'll start on our ones where we have discontinuities, and that's what makes them improper. The first two that we looked at just had one bound that was infinity. Notice this time we have two bounds that are infinity. But remember we said that with our integrals, what do we need when they're improper?
Only one side to be improper.
Yeah, we can only have one spot where they're improper. Yes. Otherwise, we said, what do we have to do?
Separate it.
Separate it out. All right. So what's the number that is in between negative infinity, infinity? That's going to be next to split it out. 0. Which is usually what we're going to pick unless something is going to be undefined at 0, which in this case it's not. So that's what we're going to use to split it up. So I'm going to go from negative infinity to 0 of 1 divided by 1 plus x squared dx plus the integral from 0 to positive infinity of 1 divided by 1 plus x squared dx. So far, so good. Okay. So on our first one, what do we need to let that negative infinity be? And we're going to take the limit as a goes towards negative infinity. And then for our second one, what are we going to let our infinity be? B. Our integrals are going to work very, very similarly, but because of where those zeros are, we do want to go ahead and work them out separately. So our first one, we have the integral from a to 0 of 1 divided by 1 plus x squared dx. What is our antiderivative of that?
Tangent inverse.
Tangent inverse of x. And we're going from a to 0. Yes, so maybe so. Which one am I plugging in first? 0. Now, a lot of the time it's okay if we leave it as tangent inverse of whatever, which you still can do here. However, because we have a lot going on with this question and we're going to be looking at two different limits, it is really going to be helpful if we remember what our tangent inverse of 0 is. Do we remember what our tangent inverse of 0 is? So basically we're going backwards. We're saying where does tangent equal 0? 0, yeah. So 1, we can think about our unit circle. So remember that tangent is sine over cosine. So we're trying to figure out where sine is 0, which is at 0. Or, this is also going to be helpful here in a minute, we can also recall, what does our graph of tangent look like?
Like a function.
Squiggly. Yeah, it goes through 0, 0, and it looks kind of like that. Which again, so that means that we are 0 at 0. There we are, okay with that. Which is then just helpful because now this goes away and I am just left with a negative tangent inverse of A. Like I said, it's not, you don't have to do it. You could get away with leaving it as tangent inverse of 0, but you're going to end up with a lot of tangent inverse of a lot of different things when you start taking those limits. So it's helpful if we can go ahead and reduce it. So then now let's do our second one. So this is going from 0 to b of 1 divided by 1 plus x squared dx. What is our antiderivative? Also going to be tangent inverse. The only difference here is that we are going from 0 to b now instead. So which one do I plug in first? B. Tangent inverse of inverse of 0 is 0, so I just end up with a tangent inverse of b. We're okay with that?
Yep.
Hopefully so. So now we can plug back in. We did our integral problem. Technically we have 2 of them this time. Now we need to look at our 2 limit problems. So I have the limit as a goes towards negative infinity. Our first one is where we got negative tangent inverse of a, and then I'm adding the limit as b goes to infinity. We got a positive there, so tangent inverse of b. Yes, no, maybe. Now we do have to be a little bit careful here, because again, remember that our tangent inverse are basically what make us, you kind of have to think about it going backwards, right? Because I'm plugging stuff into there, yes? And normally when we think about limits, we think about that we're looking for our y values, yes? Like as x is doing something, I'm looking for my y values. But because I'm plugging into an inverse function, are we with me? I'm technically looking for the x value at which tangent inverse gets closer and closer to negative infinity, or shoots off towards negative infinity. Are we with me there? So again, because it's an inverse function, we kind of have to think about it backwards. So looking at my graph, which is why I said it might be helpful here in a second, notice that I have 2 vertical asymptotes. On the left-hand side, we shoot down towards negative infinity. On the right-hand side, we shoot up towards positive infinity. Do we remember where those occur for our tangent? Huh? Is the positive one and negative pi over 2 is the negative one. So which means that this would be negative pi over 2. And this would be a positive pi over 2. So what do we get? Pi. And that would be right. Which means that if I were to look at this graph of 1 divided by 1 plus x squared, and I wanted to look at, basically I'm looking at the infinite area on both sides, okay? Your area is going to be getting closer and closer and closer to pi. So if we wanted to show ourselves why, so we actually get, it's an interesting graph. So this is what our graph looks like. Yes, no, maybe. So notice, basically at some point, both on the left and the right hand side, we're getting closer and closer and closer to 0, which is why for basically this middle kind of section is approximately equivalent to pi. But then as we shoot towards infinity, eventually I'm just adding 0 at the end. So we just get that area under the curve there in the center.